So we have Earth's magnetic field, correct? Now, Earth's magnetic field has been divided into three major components to figure out what is the field at that particular point. Okay, so the first one is what we call as magnetic declination. See, magnetic declination is the angle between the geographic meridian and the magnetic meridian. All right. Now, see, if you look at the figure, this is the geographic meridian and this is the magnetic meridian. So the angle between them is the declination. Okay. The second element, you can say, element is magnetic inclination, or we also call this as dip. All right. Now, dip is the angle between the horizontal component and the net intensity of the magnetic field. Okay. So, if you look at the figure, this is angle dip. All right. Now, the third thing, the very important thing, is the horizontal component of the Earth's magnetic field. All right. The name itself suggests this is the horizontal component. All right. So, if you look at the figure, this is the one. So we have three things: the declination, the dip or inclination, and the horizontal component of magnetic field. All right. Now, using these three components, we figure out what is the net intensity of the Earth's magnetic field at that particular point. Okay. So now see this, look at this figure. So we have the declination, you have the dip. All right. Now what we do, from the net intensity, we drop a horizontal and then a vertical. All right. Now this is angle delta, right, or what we call as dip. Now if you look at the figure, this becomes cos delta and this becomes sin delta, correct? Now cos delta and sin delta. Now using these two components, what we have is we have the net magnetic field. Okay, because if you look at this, see, cos delta or this cos component is nothing but the horizontal component and the sin component is the vertical component, correct? So what we have is we have BH is equal to B cos delta and BV is equal to B sin delta. Alright, now if you square and add these two, you will have BH square plus BV square is equal to B square, because cos square delta plus sin square delta is equal to 1. Right? So B is equal to root of BH square plus BV square. Alright, now if you take the ratio of it, that is BV by BH. So BV by BH will give you tan delta. Alright, so this, using this particular formula, that's the tan delta formula, we can figure out what is the dip at that particular place. Alright, so dip and declination with the horizontal component, this makes up the Earth's magnetic field at that particular point. Alright.